Let's look at how to prove the cosine rule in an acute angled triangle. Given acute angled triangle ABC, prove that A squared is equal to B squared plus C squared minus 2BC cos A. The first thing to do is to draw the perpendicular height of the triangle from point C, which is the top vertex, to line BA and label at the bottom there. So we've drawn the perpendicular height from C to point D. Let's say that perpendicular height is equal to H. Now we notice that the point D that we have done here in our construction separates the line from A to B into two parts. So label one part differently, let's say X, then the other part will become C minus X, because the total length of the line from B to A is equal to C. So if one part is equal to X, then the other part has to be C minus X. So that C minus X plus X will give us the total length of the line, which is equal to C. Our construction is now complete. We can begin the proof of this theorem. The proof is done using the theorem of Pythagoras. So you have to use two right-angled triangles. And the right-angled triangles are the ones that you have created by constructing the perpendicular height of the triangle. In triangle BCD, we express H as a subject of the formula, or find the value of H in terms of AC and X. So using the theorem of Pythagoras, we know that CD squared is equal to the hypotenuse of the triangle BCD is equal to BC. Therefore, CD squared is equal to BC squared minus BD squared. This is coming from theorem of Pythagoras. Substitution, CD is equal to H. Therefore, this is H squared minus BC, which is A squared minus BD. And BD is C minus X, and then squared. Now, C minus X squared is a binomial. When you are multiplying a binomial, you obviously have to be careful to make sure that you are using the FOIL method to remove those brackets. C minus X squared is the same as C minus X factor of C minus X. So we need to simplify that using the FOIL method. The negative that I have, I'm going to keep that negative because subtraction is the last thing that I'm going to do after removing the brackets by multiplication. So the multiplication here using the FOIL method gives me C squared minus 2CX plus X squared. Then after that, I can now subtract H squared is equal to A squared minus C squared plus 2CX minus X squared. This is our value of H squared in terms of AC and X. And we got this from triangle BCD. Now we label this one as our first equation, equation 1. Then from there, you focus your attention into the next triangle, also making sure that you are using a right angle triangle because the theorem of Pythagoras is applicable in a right angle triangle only. So in triangle ACD, H squared, which is CD, maybe let's start by CD, CD squared is equal to the hypotenuse, which is AC squared minus AD squared. This is also theorem of Pythagoras. CD is equal to H, therefore H squared is equal to AC squared, which is B squared minus AD squared. AD is equal to X, so that is X squared. This is already in simplified form. Now we have got equation number 2. Now from here, the first value of H that we got, the first expression represents the value of H squared. The second one represents the value of h squared. So it means the value of h squared that we got from the previous calculation is equal to the second one. So a squared minus c squared plus 2cx minus x squared. This is equal to the second one, which is b squared minus x squared. Then from there, we make a squared the subject. So transposing all numbers to the right-hand side, a squared will equal to b squared. Then the c, if we move the c, is going to become a positive c squared. Then 2cx will become a negative 2cx. Now, then x squared, if we move x squared to the right-hand side, it will become a positive x squared. So a positive x squared and the negative x squared, they become 0. So therefore, a squared is equal to b squared plus c squared minus 2ac is our expression that we have for now. The next thing we need to do is to remove x from this expression so that we can complete our proof. So where is x? X is found in triangle ACD. If you look at triangle ACD, referring to angle A, x is the adjacent side of that triangle, and we have the hypotenuse there, which is b. So adjacent and hypotenuse means cos. Applying trigonometric ratios in triangle CAD, if you look at that triangle, we can see that the cosine of angle A, the cos of angle A is equal to adjacent of hypotenuse, and the adjacent is x, the hypotenuse is b. So the cos of A is equal to x over b. Then you cross multiply to make x the subject. X is equal to b times cos A. So now that we know the value of x, you come back to this expression and complete the formula. A squared is equal to b squared plus c squared. Then minus 2cx. You remove this x and substitute x with b times the cos of angle A. This completes the proof for the cosine formula in an acute angled triangle. It's pretty much a very straightforward calculation. We don't expect people to get diarrhea from this. It's a very straightforward one. So quickly to summarize what we have done, we started by constructing a perpendicular height from point C up to point D. And the point D that we have put here separates the line AB into two parts. So we label one part x and the other one c minus x. Then using the theorem of Pythagoras, we determined the value of h squared. And we found out that h squared is equal to a squared minus c minus x squared. C minus x needs the FOIL method because we are multiplying a binomial. And then we simplify to simplest form to get your equation number 1. Then you go to the next right angle triangle available, which is triangle ACD. We also express the value of h squared using the theorem of Pythagoras, and we got h squared is equal to b squared minus x squared. That gave us equation number 2. Then you take equation number 1 and equation number 2, equate the two together because they are representing the same measurement, which is h squared. Then we make a the subject of the formula. Lastly, we had to substitute the value of x using trigonometric ratios. We know that the cosine of angle A in triangle ACD is equal to adjacent of hypotenuse, which is x over b. Then we cross multiply and make x the subject. X is equal to b times the cos of angle A. Then you bring b cos A in place of x and do substitution. Once you do substitution, you simplify your expression to get the formula a squared is equal to b squared plus c squared minus 2bc times the cosine of angle A. The proof is complete for the cosine rule. This is for examination purposes. It is necessary to just go through it and get these free marks from proving the cosine rule.